vacuum filtration. Often in lab, we need to extract out a substance that is immersed in a liquid. We could have created a crystalline compound, or crystals may have formed in a solution. We could have a cloudy solution that we want to extract out the colloidal particles. We could have created a precipitate that we'd like to analyze, but we need to get it separated out of the liquid that it's immersed in. Well, we could just use filter paper and a funnel and the aid of gravity, but let's speed things up. Let's do vacuum filtration. For that, we need a couple pieces of equipment. A vacuum flask, which presents itself as an Erlenmeyer, but with this special arm. We often in AP Chem utilize the assistance of a Buchner funnel. Now, we just have plastic Buchner funnels that separate so that we can adequately clean them, but you can see where the difference of air pressure, which I'll show you in a moment, will actually aid us. So it looks like a regular funnel, but what we're gonna do is put filter paper in here that will collect the particles we're after. Now, what we also need is thick-walled rubber tubing, because we're finally going to utilize these strange kind of jet-like features on our faucets. These are sometimes called aspirators, and they fit our faucets. Now, I know they're a pain because they really shoot out the liquid out of this jet, but there's also this arm. We know that when two fluids are traveling next to each other, if there's one that's traveling faster, it will accelerate the speed of the other fluid. So when you turn on your faucet, water, one liquid, tap water, is flowing in this direction. But there's also air out here, a fluid, and we know fluids, they're made of particles that exchange places. Gases are also fluids, we know that. And so what'll happen is then the air can't help but accelerate and then pull downward. So we're just gonna help focus the tap water so it goes right down the sink. I'm gonna put this thick-walled rubber tubing, and it just has some strength to it. So you just wanna make sure that it's nice and firmly on there. Now, this has some weight to it because it's thick-walled. So I'm gonna connect this to the arm of the volumetric flask, but I don't want this to be pulled over and then break. So when we're vacuum filtering, we definitely want to stabilize the vacuum flask with a ring stand and a clamp. Now remember, you don't have to put this over the base of the ring stand. So just to make sure that this is firmly on the lab bench, I'm going to go ahead and secure this. Now, what will happen is we are going to place our Buchner funnel over the top. So it may look similar to the filtering that you've done before. However, this will go here. So now the air that this stream of water is coming into contact with is the air from this flask, and of course the tubing. So what will happen is the accelerated water will then accelerate the gas, the air, to travel faster, which then will evacuate, and we'll have fewer particles here as compared to out here. And so the higher pressure will then push the liquid through the filter, leaving the solid behind, and then your filtrate is here. And it depends. Sometimes we're after the filtrate, and sometimes we're after the collected solid. Now, we need to make sure that we catch that solid or separate it from the liquid. So we use these filter papers that are perfectly made for that. Now be careful, because sometimes you may need to make sure that you've measured the mass of this before you place it into the Buchner funnel. Now, of course, to make sure it's securely fit, we need to go ahead and expose it to the main solvent, and in this case, it's water. So I'm going to go ahead and just dampen that, such that when I place liquid, it'll pass through and not around the base of the filter. Now, this is an OK seal. I'm not sure of the name of this, so I apologize to the inventor. But we have these special pieces of rubber, and I would definitely put the lip against the base of your Buchner funnel. And we're gonna have to just ourselves add some pressure here. And then there will be a seal so that it's just the competition between the outside air pressure and then the inside, the flask air pressure, not trying to pull, or the atmosphere not trying to push around here, but push in there. All right, so I would just get comfortable with this at first. So before you do any filtering, I would carefully turn on your water and make sure this doesn't become a sprinkler and then get everybody wet in the classroom. And you can slowly increase the amount that's going through. And you can actually begin to feel the difference of air pressure. Now, just to show us, I'm gonna go ahead and wet that down, and we can already see this is doing its job. You have a lower pressure here, higher pressure out here, and it's gonna push through much quicker than if we just allowed gravity to do its work for us. So once you're sure of this setup, then you begin taking the substance that you want to filter. And probably you want to give it a stir first. Then I would just pour in a small amount at a time. And just allow the filtering to do its thing. Sometimes you just need to be patient. Now you want to make sure that this is as clear as possible, because if there's any solid that's falling through or working around the filter, this is going to come through in your filtrate. So you'll just go ahead, make sure that whenever you filter your sample, you want to filter all of it. So after you've poured in small little aliquots, make sure that you are rinsing your beaker several times to make sure that all of the particulates have gotten exposed to the filtering. After, though, you even do the filtering, we want to make sure that all the liquid isn't remaining with the solid that we were after. So even after you do several washings of the beaker, we want to use the solvent to do several washings of the solid that we've gotten. Okay, once you're sure that you've gotten this as dry as possible, that the atmosphere has pushed the liquid through, then what I would do is extraordinarily carefully, because you don't want to lose any of your solid, with forceps or possibly with a scoopula, just kind of encourage one of the sides of your filter paper to loosen from the Buchner funnel. And then we're almost there. Such satisfaction that you got all the liquid through. All right, then we'll go ahead and remove what you filtered very carefully. Again, you want to make sure that you're not, losing any of this solid. All right, but this is still going to be wet. So what we need to do is get probably another piece of filter paper. What I would do is with pencil, put your initials or some other marking to identify this as yours. Then we need to let this dry. We need for all of that liquid to vaporize. So depending upon time, we'll either allow these to sit just out overnight. Sometimes we may need to cap this with an overturned beaker just to still allow vapor to escape, but we don't want any dust to settle and so on. Or we may place it in our warming oven, just at a nice low temperature, greater than the classroom, to just help encourage that liquid away, but not enough to decompose or alter your compound. And then you'll continue with the analysis that you need to do. So that is vacuum filtration. The only other thing, we want to make sure that we've cleaned everything. So after you're done, you want to rinse your Buchner funnel. Please feel free to separate it, really give it a good rinsing, because as you see, some things collect in that bottom funnel. We want to make sure too that we have fully rinsed this out several times, maybe even taken a test tube brush and scrubbed it out, because that's a bummer if you go to reach for something and we know it's dirty when we get it. So we want to return things the same, hopefully better than we found them. Enjoy the lab.